Welcome back to the Foundation in C# course. We are currently in Module 6, and this lesson we're going to be covering interfaces. So what is an interface? How do we use it? Why do we use it? And when do we use it? The key questions to ask. So let's dive right into a new project. We'll create our console application. Make sure it's the .NET framework. And we'll call this the interface demo and interface demo app. And make sure it's 4.7.2. And we'll hit create. Once that's created, we'll add our console.readline at the end. And now we're ready to get started with interfaces. So an interface, and let's just write this down so you have it, because it's kind of important to grasp what an interface is. An interface is a contract. So what it does, it says, this is what a class will do that implements this interface. Okay, and the implements is a key word there. So classes implement interfaces. Okay, we just learned about inheritance. So classes can inherit from another class, but in this case, it's not inheritance, it's implementation. And implementation essentially just says that, yes, we conform to whatever contract we say we implement. Okay, so that's generic. Let's make it a little more practical. The way to think of an interface is to think about, real life. Let's look at power cords. Okay, it would be chaos if every power cord was different in how it plugged in. Okay, so if some had 5 prongs and some had 8 and some had 2 and some had 1, that would seem chaotic and nothing would really work. Your house power would have to be like, physical wires that you twist on the ends of your power cables, and that just wouldn't be good. And so designers of houses and electrical systems and all the rest, I'm not even sure who came up with it originally, but designers came up with this plan where they said, we're going to standardize on an interface for your house's power. Now in the US, it's 2 flat prongs up top, and then down the middle, down below, is a more rounded prong. That's the standard. Now in the UK, it's different. In other countries, it may be different as well. But whatever country you're in, the shape doesn't matter as much as the fact that it's standard throughout the country, or at least hopefully. That's an interface. So now what we've said is the contract is this particular shape and this number of prongs. And then everybody who wants to implement that interface does so by making sure that theirs fits into the right slots. Okay, that's how we're thinking about these interfaces in our classes. We're creating a contract that says this is what it's going to look like so that you can expect certain things. So let's see this in code. And let's start with a class that is public class. Let's go with keyboard. All right. There we go. So a keyboard class. And in it, it has a method that is, let's call it void connect. So this method will be called whenever you want to connect the keyboard to the system. So the system will say, oh, there's a keyboard. Let's turn it on or enable it or whatever by saying, hey, it's, connected. Okay. And then we haven't learned about events yet, and we'll get to that. But typically what happens is we'll fire off an event when the keyboard is pressed. So if you press the T key, it broadcasts out and says, hey, the T key was pressed. But we haven't learned about how to do that yet. So we're going to do it a little bit differently because this is just a demo. And so we're going to have the idea that the caller is going to keep asking, hey, what's being pressed? What's being pressed? What's being pressed? And so we're going to have this public void current key pressed. And that's going to, in theory, tell the user, hey, this is what was pressed. Okay? So those are the two methods. Now, what if we had another class, public class, let's call this game controller. It's very generic, but it illustrates the point, okay? And this has a bunch of things, but public void connect is one of them. Because you have to tell the controller, hey, you're connected. And again, we don't know about events, so we're going to say public void current key pressed, and we're going to have something called. Now you say, well, hey, wait a minute. We got some repetition going on here. Maybe we should have some class inheritance. But really, I'm not sure we can find a common ground here. They both connect to a computer, but game controllers connect to a game system or a computer. So that's not really common ground. Yes, they both have a connect method, but that's not an is-a relationship. So finding that common ground between these two, you could say they're both peripherals, meaning there's something that is on the outside of a computer that connects in. And that kind of works, and maybe even connect would fit in that peripheral base class. The problem is that current key pressed would not, because not everything that's a peripheral is has some kind of keys to it. For example, my webcam does not. Therefore, it wouldn't have current key pressed. Therefore, it's either not a peripheral or a peripheral can't have current key pressed. And you say, well, at least Connect would though, right? Well, I also have a few things that plug in USB, but they're just for power. And that's technically a peripheral, but you don't connect to it. So that might not work for that either. So what it really comes down to is, even though they have similarities, these two things are not the same thing. But you may say, you know what? I want to have a list of type something, which we'll put string in here for now, but it's not string. A list of something that is our controllers. Okay? And you want to do equals new list of something, but string is not it. And I could say, well, list a keyboard. And that's cool, but how do you put game controllers in there? Because we want a game controller to also be available as an option. So how do we do this since we can't have a base class we can put in here? And that's where interfaces come in. An interface, let's say public interface, not public class, public interface. And the public interface always starts with a capital I and then your words. Okay, so in this case, computer controller. Controller itself is a keyword, so let's not use just iController, but iKeyboard or computer controller, like so, and now that's an interface. This is a contract. Okay, so again, the standard is that we have the Pascal casing, meaning each word gets its own capital letter, but before all of it is a capital I. And this is one of those standards that is so standard that you don't want to not do this. In fact, it would be highly discouraged to do anything else because the rest of the world starts an interface off with a capital I. And there's going to be a reason for that. I'll show that in just a minute. But for now, an interface starts with a capital I and then has Pascal case. Now, an interface, like I said, is a contract. It's not actual implementation, meaning it just says, here's the things that a class that implements me will do. It doesn't actually do the work like a base class does the work. You could have actual methods with code in them. You could have properties that actually hold values. But with an interface, there's none of that. It's just definitions. So since everything in a contract has to be public, because we don't want to have anything hidden from a contract, we don't want any hidden clauses, so everything's public. Therefore, we don't include the word public because of the fact that it's implied. So I created an interface that says, okay, these are the things that a computer controller will have. One of them is a connect method. Now you see how similar that is to my connect method here? The difference is there's no public at the beginning, but it still says void, it still says connect, it still has my parameters, if any. But then instead of curly braces for the code, it has a semicolon. And the reason why is because we just want the signature line of our method. The signature line is this line right here. Now we drop off the public and we add a semicolon at the end. We were saying we're done. So a signature line defines the return type, it defines the name, and it defines any parameters that you have. Okay, so those are the things that it defines. Now, let's create one more for this as well. So current key pressed. Semicolon. Now there's an interface that defines and brings some commonality across different things so we can use this in our list. So let's do this. Let's implement the iComputer controller interface on the keyboard. So we say iComputer controller. Now, doesn't that seem a little weird? Because it looks just like our inheritance. We put it as a colon, and then we put our interface. And yes, that's exactly the same process we do for our inheritance, which is why that capital I syntax is so important. Because the capital I indicates this is an interface, not a class we're inheriting from. And why is it important to know that? Well, because you can inherit from a class and you can implement one or more interfaces. So you can have 5, 10, 15 things at the end of this, but you can only have one base class. Okay, so, and also the base class comes first. You can't have it second or third. So I just implemented, and we'll show that in just a minute. But for right now, I just implemented the iComputer controller. Now nothing happened. And the reason why nothing happened is because we already had these two methods. But what if we didn't? So let's get rid of those. And now for the game controller, I'm going to implement the iComputer controller interface, and it yells at me. It has that red squiggly underneath. If I do a control dot here, it will say, hey, do you want to implement the interface? And yes, I do. Don't explicitly implement, just implement. Okay, so now we have two methods, a connect method and a current key pressed method. Well, how did it know to do that? Well, that's what the contract said that we would do. Therefore, that's what it put into my class. Now it throws this new not implemented exception because there's no code in here yet. And we don't really need that for this demo. But now these two classes implement the same interface. So up here, I can say iComputer controller like so. And now I can put anything I want in there as long as it implements the iComputer controller interface. So I could say keyboard equals new keyboard. I can say game controller, let's call it controller, equals new game controller. Let's call it game controller after all. Otherwise, we get messed up with controllers. But now I can say controllers.add a keyboard and controllers.add a game controller. Notice that both work just fine. If I do my for loop, for each loop, for each, and we'll say iComputer controller. We could have said var, but I want to kind of show you that. Controller in controllers. We have access to the connect and current key pressed methods. Now that's all we have access to. So let me just show that off. So we can have public void. Let's go with battery level. Let's not go battery level. That's a prop. Let's do prop. And we'll say it's an int. That's fine. So battery level is how much battery is left in the game controller. Keyboards, unless they're a wireless keyboard, don't have batteries. So we're going to have instead the connection type for like USB or something else, which would probably be an enum. But again, for this example, that's fine. So now we have different properties that are unique to each of our classes. If we come back up here and do our controller dot again, we don't have access to those properties because we only are using the iComputer controller interface. So we say, hey, you know what? This contract says we have two methods. Therefore, there's the two methods we have. Okay, so it's going to do just those two methods because that's what it knows for sure that they have. Okay, so where is this useful? Well, you just saw that if we have different things that are not quite the same, they can't inherit from each other, but still we want to store them in a list together, we can use the interface. That's one possibility. Another is when we want to have if we want to create a contract that maybe somebody else is going to implement, and we don't really care. It can be, one type implements it or 1,000 different types implement it. We just need to run a certain set of commands or get certain values out of something, regardless of what it is. There's one that's built into the .NET framework that is really, really helpful, and that's called iDisposable. So an iDisposable, let's just implement that down here on game controller. So I do comma and I say iDisposable. Now again, I have not implemented it. So I control dot and say implement. Notice it's going to add one method. It adds the dispose method. So I could say, do whatever shutdown tasks needed. So the dispose method is going to get called whenever we shut down this class or get rid of the class. So the reason that's beneficial is because Microsoft has given us this thing called a using statement. Using, and we can use whatever is iDisposable. So we can say game controller GC equals new game controller. And the benefit here is that since it's in a using statement, and since it's an iDisposable, the using statement doesn't have to figure out how to shut this class down at the end. It knows that it has a method called dispose. And so when we get to the end of these curly braces, the using statement will automatically call gc.dispose. If we crash with an exception, it will still call gc.dispose. No matter what happens, it will call gc.dispose at the end. Now, the benefit here is think about working with images. If you load an image into memory, which an image is very, very large compared to our normal memory usage of strings and integers, if you load an image into memory and you're working with it and you forget to properly unload that memory at the end, which is very, very common to forget that, then .NET will hold that memory forever. And so your application, as it goes through more and more images, gets bigger and bigger and bigger. It uses more and more and more RAM. Well, the using statement says, you know what? When you're done working that image, when you hit this closing curly brace right here, I'm going to dispose of that image properly. So we're safe. Our memory usage goes back down because we're no longer storing that image in memory. Another potential here is for connecting to a database. If you open a connection to a database inside a using statement, so you have to be iDisposable, but if you do that, then no matter what, before the end or by the end, it's going to close that connection. It used to be in the old days that we have these awful problems of hundreds of open connections to our server when the apps were all closed, because the connection stays open even after an application closes. We'd actually have to reboot the server in order to clear those sessions out, and that was not a good idea. So this allows Microsoft, who's already written the code to call the dispose, it allows them to call that dispose even on classes that we create down the road. Okay, so that's one of the big powers of interfaces is it allows us to say, I don't know who you are, but I do know that you implement this interface. Therefore, I do know I have access to whatever the interface says you do. Okay, so those are some definite reasons to use interfaces. Now, at first in your development career, when you're starting out, when you're starting to learn object-oriented programming, you probably won't use interfaces that much. They may seem underpowered or not terribly useful. I was there, okay? That's kind of the way I looked at interfaces for a long time as I was learning. But I learned the hard way, okay? I didn't have somebody to teach me the easy way to learn C#. So it took me a while to figure out some use cases for interfaces to the point now where interfaces are half the code, it seems like, that I do. Because when you get into these solid principles, which if you're at this point in the course, you're not ready for solid yet. Solid is some advanced stuff. It takes what we're learning now and it takes it to 11. I mean, it just cranks it up. But what solid talks about is the idea of how to architect your application in such a way that it's a bunch of modular pieces that can get pulled apart and replaced one at a time instead of redoing the entire application to fix one piece. Okay? So at that point, interfaces become critical. They are extremely important. So knowing how to use interfaces is important, even if you're not yet to the point where you're ready to use them naturally. And that's okay. Don't use something just because you've learned it. Now, in test, yes, do use it because you've learned it. But when it comes to building actual applications, don't just say, oh, well, I need to use this because everybody does. Don't do that. Know the reason why you're using it or don't use it. Okay? So that's just kind of my step back piece of wisdom here. Okay. So I had mentioned the fact that we can have both an inheritance and an implementation going on. So let's add some inheritance to game controller. Let's actually go the other way. So we're going to use this as the parent class, since it's pretty generic. Let's create a public class, and we'll call it battery powered game controller. That's pretty long, but that works. And what this is going to do, oops, no parens. I was wondering why that was acting weird. If something acts weird, don't just assume that the editor is messed up. Figure out why. Because more likely it's something you did, not something the editor did. So we're going to move this down here because not all game controllers are battery powered. But this is a game controller. It's just a battery powered game controller. So we can say that battery powered game controller is a game controller. So now we have this set up with this relationship, but that's it. We have not implemented any interfaces on battery powered game controller. Let's come back up here to our list, and let's create a new battery powered game controller. Let's call it battery for now. It's not a great name. It's an awful name, but that's okay. I'm going to say controllers.add battery. Notice that I added it, not a problem. Even though we don't implement, we're looking for the iComputer controller. There's no interfaces at all, but we don't implement the iComputer controller specifically. So how is it that we have the ability to put that in the list? Well, we inherit from game controller, and game controller has these two interfaces. Therefore, we can assume, well, we know for sure that battery powered game controller implements the iComputer controller interface because game controller does. It's a little convoluted, but since our parent implements an interface, therefore we implement that same interface. So with that, we don't have to add any interfaces. However, what if we created another keyboard? So let's call this keyboard, so public class battery powered keyboard. And this is going to get that same battery level. We can't have an inheritance here. We can't double inherit, and because a keyboard is not a game controller. But what we could do after we inherit from keyboard is we could create a new interface, public interface, and call it battery powered. And it's going to have one property, can't be public. Messed that up. There we go. Int battery level. Notice it has get and set because it says both of those methods will be present, the get and the set. But there's no semicolon at the end because there's semicolons here. So now we have an iBattery powered interface, which the keyboard can implement. It already has. And so can the game controller. Now, order is important here. You have to inherit first and then implementations. And you can have multiple if you want, like this one does, or just one or none. But it has to be the order of inheritance first, if there is inheritance. If there's not, no problem. So now we could come up here and we could create another list, a list of iBattery powered. We'll call it powereds. And we can say powereds.add. We'll do a new here. Actually, we just say battery. And that works. If you say powards.add keyboard, that won't work because the keyboard is not battery powered. It does not implement that interface. But we do know that the battery powered keyboard, we can call this, let's call it battery keyboard. So the battery keyboard can be added. Okay, so this is the way interfaces work. Okay, they are passed down to child and grandchild relationships in inheritance. You can have more than one. They have to come after the inheritance, if there is any, and you have to fully implement them. You can't say, well, you know what? We're not going to do that. You do, then you're in violation. You cannot have this partially implemented. It's a contract. You sign the dotted line, this is what we're going to do. The compiler will force you to fully do that, not partially do it. I'm not going to re-implement that. They'll add just the method I'm missing, which is nice. The other thing you cannot do is you cannot say, well, this actually returns a string, because that's not a valid implementation. The iComputerControlled says, where is it? It's up here, that the current key press will return void as a nothing. But you're saying that it returns string, and that's not the same thing. So you have to implement the interface specifically and fully. Okay? You can't skimp on things. You can't change things. You have to implement it fully. That doesn't mean you can't have more stuff. For example, the iComputerController does not have dispose, and that's okay. Now, the other thing you can do, and this is where it gets a little fun, is you can say, well, you know what? For the iComputerController, that really should be also have iDisposable. Do you see how I just implemented the interface iDisposable on the iComputerController? I said, okay, this is the contract you're working with, but I'm going to inherit from, and the wording here is a little weird because it's not really inheriting, it's not really implementing. What it's doing is it's combining contracts. So it's saying the iComputerController will have these things here, but it's also going to have everything that's in the iDisposable contract as well. And in fact, you can stack these if you want to. You can have more than one. So I could say battery powered as well. Now I just broken all my classes because none of them fully implement this. But if I just do this, notice how keyboard is yelling at me because does not have an dispose method. But if I do this drop down here and say implement interface, it's going to implement the dispose method. And there you go. So now everything that's an iComputerController is also iDisposable. So you can kind of merge those together. It's not really a inheritance. It's not really an implementation. It's more just kind of combining these together into one larger interface. And that can be helpful in certain circumstances. Now, also, a trick we learned in inheritance is we can use that if check and say if controller is, well, guess what? We can do the same thing here. We can say game controller and then say GC. So now it's going to say, hey, if this iComputerController is a game controller, then put it into this variable and now you can call it. You can say GC dot and have all the game controller stuff. that's associated with game controllers. And that's one thing you can do, but then you can also do the same thing with other interfaces. So if controller is battery powered, I can say, let's call it, we use powered. We have not used powered, looks like. Nope, we haven't. Great. So battery powered. So now you can say powered dot, notice you only have access to battery level. But just note that controller has access to connect current key pressed and disposed because it is a computer controller. So you can actually use two different variables to talk to the same actual class. One for powered, one for controller or computer controller. So there's a lot of things you can do here. A lot of ways you can really make interfaces work for you. A lot of ways to get the information out, to use them together with other objects. And it's just a really powerful tool to have in your toolbox. So let's look at the tip for today. And the tip is that interfaces are a contract. Use them as types when you need common functionality. And that's where I put like list of computer controller, not list of keyboard, computer controller. That way I could use that common functionality between all computer controller classes, whether it's game controllers, keyboards, battery-powered keyboards, or battery-powered game controllers. Okay, and that could even be something that I didn't anticipate when a developer comes down the road and creates another type, maybe a mouse. That could still be a computer controller. Okay, so your homework is to create an iRun interface and apply it to a person class. Okay, and also an animal class, because both people and animals run. And then store both types in a list of iRun object. Okay, so basically just get your feet wet, create an interface, and then play around with it. Okay, now one note, I didn't do it on. You know what? I'm gonna do it right now because I don't want you to miss this. I'm gonna come back here. I'm gonna move all of these over into files over here because I don't want them to end up staying in this program.cs. So just note that I'm going to do this every time, even if I don't show you, but you don't want to leave them here. Okay, so we're just going to move them all over right now with a control dot on every one of them. Okay, so go ahead and create that homework, and if you have to, come back to the source code and look at it, make sure you understand how to do that. And then once you're done, move on to the next lesson.